Hello, Algebra 2. Today we are looking at Chapter 10, Lesson 4, which is Inverses of Trigonometric Functions. So we have evaluated trigonometric functions for a given angle. You can also find the measure of angles given the value of a trigonometric function by using an inverse trigonometric relation. And so looking at this, the right side of the table is your inverse of your normal function. So example 1, finding trigonometric inverses. Find all possible values of inverse cosine of the square root of 3 over 2. So here we are looking at our x values, and we have 2 of them. And we are just looking between 0 and 2 pi. So if we look back at our unit circle, we know that 0 is over here and pi is over here. So we're just looking at one full circle. And then we would write it out as the square root of 3 over 2 equals cosine of pi over 6, because that is the first one. And then the square root of 3 over 2 equals cosine of 11 pi over 6, because that is our second one. And then step 2, find the angles that are coterminal with angles measuring pi over 6 and 11 over pi 6 radians. And then this would be your answer. Because more than one value of theta produces the same output value for a given trigonometric function, it is necessary to restrict the domain of each function in order to define the inverse trigonometric functions. So for sine of theta, it is restricted to quadrants 1 and 4, and it would be negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. For cosine, it is restricted to quadrants 1 and 2, and that is 0 is less than or equal to theta, which is less than or equal to pi. And then for tangent, it is restricted to quadrants 1 and 4, and it would be the same as sine, which is negative pi over 2 is less than theta is less than pi over 2. The only difference is that it's not less than or equal to, it's just less than. So inverse trigonometric functions, the inverse sine function. This table will show you your symbol, your domain, and your range. And so this is another good one just to have on hand if you want to screenshot it or write it down or print it out. That would be awesome. Example 2, evaluate each inverse trigonometric function. Give your answer in both radians and degrees. So cosine, inverse cosine of negative square root of 3 over 2. First you would write the negative square root of 3 over 2 equals cosine of theta, because that would get rid of your negative 1, and so then you're no longer looking for your inverse. And then you would solve it out. You'll see that 5 pi over 6 is what would give you the negative square root of 3 over 2. And then you'll write out inverse cosine of negative square root of 3 over 2 equals 5 pi over 6. Or you can write the inverse cosine of negative square root of 3 over 2 equals 150, because 150 would be your degrees if you look at your unit circle. Example 2b, evaluate each inverse trigonometric function and give your answer in both radians and degrees. So if we're looking for the inverse sine of 3 over 2, the domain of the inverse sine function is negative 1 is less than or equal to a, which is less than or equal to 1. And so 3 over 2 is outside of the domain, so it would be undefined. Example 2a, find each inverse trigonometric function and give your answer in both radians and degrees. So inverse sine of negative square root of 2 over 2, we need to find the value of theta for negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2, or whose sine is negative square root of 2 over 2. And so here we would use the y-coordinates of the points on the unit circle, and we see that it's right here. And so we would put negative square root of 2 over 2 equals sine minus, because it's a negative, pi over 4. And then we can write that as inverse sine of negative square root of 2 over 2 equals negative pi over 4, or inverse sine of negative square root of 2 over 2 equals negative 45. And don't forget to make them negative because they are both negative. Here's another example, inverse cosine of 0. So we would write 0 equals cosine theta. We need to find the value of theta for 0 is less than or equal to theta is less than or equal to pi, or whose cosine is 0. So here we are using the x-coordinates of points on the unit circle, which we see is a 0 here, which is pi over 2 or 90 degrees. So we would write inverse cosine of 0 equals pi over 2, or it would equal 90 degrees. Example 3, a painter needs to lean a 30-foot ladder against a wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? So step 1, draw a diagram. The base of the ladder should be 1/4 of 30, so that is 7.5 feet from the wall. The angle between the ladder and the ground, theta, is the measure of an acute angle of a right triangle. So what we are looking for is this angle right here. And so to get that, just looking at this triangle, it's a right triangle. So we are going to use cosine, which is our adjacent over your hypotenuse. So step 2, find the value. Cosine equals 7.5 over 30, which is 0.25. And then you will put theta equals inverse cosine of 0.25, and that will give you about 76 degrees if you plug it into your calculator. And down here, this box is showing you how to type it in. And then since it's 75.5, we would just round that up. Example 4a, solve each equation to the nearest tenth and use the given restrictions. So we are looking for sine of theta equals 0.4. And then our domain is negative 90 degrees is less than or equal to theta is less than or equal to 90 degrees. So these restrictions are the same as those for the inverse sine of the function. So writing this out, we would do theta equals inverse sine of 0.4. And if you plug it into your calculator just like this, you will get that it is 23.6 degrees. Okay. Looking at the next one, sine of theta equals 0.4 for positive 90 degrees is less than or equal to theta is less than or equal to 270 degrees. So the terminal side of theta is restricted to quadrants 2 and 3. Since sine of theta is greater than 0, we need to find the angle in quadrant 2 that has the same sine value as 23.6 degrees. So we would do theta is approximately 180 degrees minus 23.6 degrees, which would give us 156.4 degrees.